Good morning, dear students. How are you all? I hope you are all doing good and studying really very hard. Okay, so let's solve one more problem of this book, Irodo, and question number is 21, 1.21. Let's read this question. At the moment t is equal to 0, a particle leaves origin and moves in positive direction of x-axis. Okay, so particle is moving along x-axis and particle is at origin at t is equal to 0. So this is really a simple situation initially. Okay, fine. Let me draw this at least. Particle is moving along, suppose this line, or let me draw like this. Okay, so particle is at origin at t is equal to 0. Okay, fine. And velocity varies, its velocity as a function of time is given. V is equal to V naught. V naught, well, we know that V naught is 10 centimeter per second, and yeah, time tau is constant. This tau is constant. So actually we have been given velocity at any time t. Suppose at any time t, at t is equal to t, particle has velocity v. So v at any time is given as 10 1 minus t by 5 centimeter per second, students, because v naught is in centimeter per second. Okay, now what we have been asked, first find the x coordinate of the particle at the moment of time t is equal to 6 second, 10 second and 20 second. This is relatively easy question because we just have to find the x coordinate using integration. Yes, we will be able to find. Let's solve this part first and then we will discuss the second part. So in the first part, as we have given velocity as this, we can write v is equal to dx by dt, right? Rate of change of position. This is equal to 10 minus, I am multiplying this inside, 10 minus 2t, and this is in centimeter per second. So obviously if I integrate this, then I will get the position also in centimeter. Okay, let's integrate. So I will write dx is equal to 10 minus 2t into dt, and at t is equal to 0, particle is at origin, so x is equal to 0, and at t is equal to t we don't know, but let's solve for a general value of x. So at t is equal to t, suppose particle is at x coordinate. So if we solve this further, we will get x minus 0. X minus 0 is equal to what we will get. This will be 10t minus t square integration and 0 to t. So we will get x is equal to 10t minus t square. This 2 has been cancelled because when we will integrate, t square by 2 will come and 2 will get cancelled. So this is what we have got. Now they are asking position at t is equal to 6, 10 and 20. So just put it at t is equal to 6 second, x is equal to 10 into 6, 60 minus 36, right? So we will get 24 centimeter. Fine. At t is equal to 10 second, if you put t is equal to 10 second, 10 times 100, so 100 I am getting is 0. That means at t is equal to 10 second, particle has come back to origin. Okay, fine. And at t is equal to which time? At t is equal to 20 seconds. So we just have to put time, and t is equal to 20. I will get x is equal to, let's write 10 into 20 minus 20 square. So I will get 200 minus 400, and this is minus 200 centimeters. So obviously particle has gone to left side, right? It now at t is equal to 20, particle will be on the left side of x is equal to 0 of origin. So this is the first part. This is relatively simple part. Okay. Now what we have been asked in second part, the moment of time when particle is at distance 10. Okay, when a particle is at distance 10, so suppose this is the time when x is equal to 10 second. I could have said this is as t1 also. This is t is equal to t1. So we will just solve for general t only. Why bringing one more variable? So we know that x is a function of time is 10t minus t square, and we want this as 10 centimeter. This is what we want. So let's solve this. We will get t square minus 10t. I am taking all this on the right hand side, so t square minus 10t plus 10 is equal to 0. This is the equation. Now this is simple quadratic, and we will solve it. We will get minus b plus minus under root of b square minus 4ac. 4 into a is 1 and c, this is 40, divide by 2a. So this is 5 plus minus. We have got here root 60, and divide by 2 is also there. Root divide is whole divide, root 60 divided by 2, and root 60, 15 4 is 60, right? So this is 5. Let me just check if I have done correctly. Yeah, I hope it is all right. So root 60 we can write 15 into 4, or I will write 15 into 4, 2 will come outside the under root, and I will get plus minus root 15. So we have got two times, right? So at t is equal to 5 plus root 15 is one time, and other time is t is equal to 5 minus root 15. So yes, we have got mm, this two times. Yes, okay, fine. And I think this is right also. Let's write this is t1 and this is t2, because we have seen at t is equal to 10 second, particle will come back to origin, right? So particle must have gone in the positive direction, and then it has come back to the origin at t is equal to 10 second. So yes, I can fairly say at t is equal to 5 minus something, it must be going in forward direction, and then at t is equal to 5 plus something, but it is less than 10. Obviously it is less than 10. So yes, it has come back to the same position before 10 second, right? So this is not this is around this is 9 second, maybe 8 or 9. It is between 8 and 9. So yes, I can say this is true. And obviously we can find at what time particle has changed direction. We can just put velocity is equal to 0. So we are getting at t is equal to 5 second. At t is equal to 5 second, particle's velocity has become 0. And if you want to find what was the coordinate at that point, yes, we can just put let me write it here, v is equal to 0, right? Is equal to 0, this is the turning point, and at t is equal to 5, if you want to find what is the coordinate, so 10t minus t square, 10t, 50, 50 minus 25, so this is actually 25 centimeter. So particle has come back from the 25, fine. So we have been asked the when particle is at distance 10 centimeter from the origin. So when it is at x is equal to plus 10, this is one case which we have just solved, right? So if particle is on the right side, 10 centimeter right side on the origin, then this is the case we solved it. Yes, so particle will cross this position two times while going in this direction and then coming back to the origin. Now one more solution will come here, because in question they have just asked at what time particle will be at distance 10 centimeter from the origin. So if particle is on the left side and x is equal to minus 10 at some time, t is equal to t3, let's say, particle is at minus 10 centimeter position also, then also I can say particle will be at a distance 10 centimeter from the origin. So we have to solve it again for x is equal to minus 10, and we know that x is 10 t is minus t square. So let's solve this quadratic fast. T square minus 10t minus 10 is equal to 0. Now again we have to solve the simple quadratic. Now we will get t is equal to minus b, that is minus plus minus b, plus minus under root of b squared, that is 100 minus 4ac minus 4ac. 4a is 1, so this is going to be addition here because minus minus will get plus, you know very well, divided by 2. So what we will get, this is 5 plus minus under root of 140. Find 140, and yes, 140 can be written as 35 into 4. So just write it because 2 is going to come out and it is going to get cancelled. And yes, we have got here two answers. This is t is equal to 5 plus root 35 because 2 is 2 and 2 is going to get cancelled, and another one is 5 minus of root 35, right? So 5 minus root of 35, this is going to be negative. So this time cannot be negative here because we are not talking before the t is equal to 0 event, we are talking after t is equal to 0 events, and we know the information only after the t is equal to 0. So we should cancel this one, and yes, this is t3. So there are three times when a particle is at a distance 10 centimeter from the origin, and it was really logical. There must be three times, as we can see particle has gone in a positive direction, then it is coming back to the position, and then it continuously moving in the negative direction. So yes, while going toward a positive direction, while going, then coming, and then on the left side, right at this point, while it is moving in this direction. So yes, okay, fine. Now let's solve this last part, the distance covered s. Distance s covered by the particle during the first 4 seconds and 8 seconds. Okay, fine. Now, yes, this is really interesting. And here is when students generally make mistakes. Most of the students make mistakes here only. And the point they actually forget is that they forget to see that particle's velocity has become 0 at t is equal to 5 seconds. They must develop this habit to see if particle has taken a turn. So yes, at t is equal to 5 second, particle took a turn, right? At t is equal to 5 second, particle's velocity became 0. Particle came to rest, and then it turned around. Let me draw this with another pen. So particle went like this first, like this, in this direction, and then particle came back, and then it just completely in the it continues to move in left direction. It continues. So this is the motion of particle. So particle, when it is moving in positive direction, we can see that distance and displacement are same till t is equal to 5 seconds because it is moving continuously in same direction. But when it starts to come back, we are seeing the distance will never decrease because the more whatever distance, whatever steps it will take, it will add to the distance. Whatever length he will cover, it will be added to the distance only. But displacement is the distance between the initial and the final position. So if we come back to the initial position itself, x is equal to 0, then displacement becomes 0. But distance will be added. Distance will be when it is going from t is equal to 0 to t is equal to 5 seconds. Let's say it has traveled 25 centimeter in the right direction, and then at t is equal to I don't know which time, but yes, it has, yes, we already calculated that t is equal to 10 seconds, right? At t is equal to 10 second, particle has come back to origin. So at t is equal to 10 second also, this is at t is equal to 10 second, particle has come back to the origin. So while ongoing journey, it has traveled 25 centimeter, and in return journey, it has traveled again 25 centimeters. So total distance in 10 seconds, if somebody asks us if total distance in 10 seconds will be 25 plus 25, 50 centimeter, but displacement will be 0. So you must always take care that you must always find at whatever interval in which you have been asked the distance mainly, you must see if particle velocity becomes 0 in between that interval. This you have to check. So yes, they are asking distance covered in first 4 seconds and 8 seconds. So in first 4 seconds, yes, in first 4 seconds, the particle did not come to rest because particle comes to rest at t is equal to 5 seconds. So till 4 second, distance and displacement are same. So I will just find the final position and get the displacement. At t is equal to 4 second, what is the position? So displacement will be final position minus initial position, and the same will be the distance for t is equal to 4 second, because particle did not take any turn till that time. So I am solving this first part. So in C case, uh, in uh, in first 4 second, I will say distance. Distance is equal to displacement, and which is, we know that, which is equal to final position minus initial position, right? So at t is equal to 4 second, we know that x is equal to the position as a function of time is 10t minus t square. Let me check it once again, because I remember this is yes, 10t minus t square. So displacement, magnitude displacement will be modulus of, now just let me put 4 second, this is will be 40 minus 4, so that's 16. Final position minus initial position is x is equal to 0. So we will get here 40 minus 16, what is it? 24. Yes. So 24 centimeter. So in first 4 second, distance traveled and displacement both will be equal to 24 centimeter. But in first 8 second, we know that particle has started travel like this along the straight line. So at t is equal to 0, particle started moving in this direction, and at t is equal to 5, its velocity became 0. So it went like this, and then it traveled back. So this is t is equal to 5 second. Let's say this is t is equal to 8 second. So we must find what is the x coordinate at t is equal to 8 second. So at t is equal to 8 second, x coordinate is equal to 10t minus 10 into 8, 10 into 8 minus 8 square. We will get 80 minus 64, and this is equal to 16 centimeter. So yes, at t is equal to 0, particle is at x is equal to 0. At t is equal to uh, 5 second, particle is at 25 centimeter, and we are seeing that at t is equal to 8 second, particle is at, oh, let me write it here, particle is at plus 16 centimeter, right? So how much distance particle traveled? Let's say this is x1, this is x2, this is x3, and this is again when it come back, so again it come back to x2, right? So total distance, let me write it this way, a, b, and this point will be c. So distance will be equal to mod of ab plus mod of bc. This is simple. So mod of AB is equal to, we know that 25 final position minus initial position. This is modulus plus, again displacement will be final position minus initial position. So final position is plus 16 minus initial position is again plus this, and I have to take the modulus of both the terms. So this is going to be 25 plus, I will get 25 minus 16, what we will get, modulus of 9, actually minus 9, and modulus of 9 will be equal to 25 plus 9, answer will be 36, I think. Now let me think, 34 centimeter. So distance traveled in first 8 second is 34. Got it? This is how you calculate. And yes, obviously there is a method of integration also, but when you do integration, you must remember that, suppose for the first 8 second, if you want to calculate displacement using integration, then it will be v dt. You must integrate it from t is equal to 0 to t is equal to 5 second first. This is the time at which particle velocity becomes 0, and you must put mod. This is the displacement particle has before its velocity become 0, plus after that again it traveled some distance from 5 second to 8 second. It has displacement from 5 second to 8 seconds. So again v dt, and you will say t is equal to 5 to t is equal to 8, and you solve it. Velocity function will remain same. V is equal to what was that, 10, I don't remember it, 10 minus 2t, velocity 10 minus 2t. So this is the function. You have to integrate this function 2 times, and finally you have to take mod. V is equal to 10 minus 2t centimeter per second. So this is how, students, you solve such questions. This was really good questions. Only the third part. Yes, second part is also because there was 3 times, and you may not be able to see all 3. But yes, you must have a practice of these questions, such type of questions. Okay, students, I hope you learned something from this video at least. If you really learned something, then you like this video, give your comments because it will motivate me. Also, if you have not subscribed to this channel, then do subscribe, and do not forget to press that bell icon right down here. There is a bell icon. You must press it, because if you press it, then you will get notification every time I upload videos. And yes, I'm going to solve more problems here, and as I will get more time, I will try to upload video lectures of topics, right? So this, it is going to be really helpful and good learning experience. So do subscribe, and okay, students, thanks for watching. Happy learning.